Welcome. My name is Bob Tickleman. I'm a Principal Microsoft Technical Trainer. I'm excited to be your guide for this learning path number 7, Implement Secure Cloud Solutions. This learning path is made up of 3 specific modules or recordings, and this one is going to implement the Key Vault, and we're going to describe what Key Vault is and the characteristics of it and why you might use it. In the next recording, we'll take a look at implementing managed identities, what they are, and we'll introduce some of that here. And then in the final recording, we'll take a look at implementing app configuration and ways to manage things like feature flags in an automated method in a secure manner. Module number 1 is implementing Key Vault. So we're going to jump in and take a look at what is Key Vault in its different forms. How do I provide security using Key Vault, and what forms of authentication and authorization is going to be granted to me through the Key Vault itself. And then we'll take a look at ways to retrieve and manage the secrets and the secure information inside of the Key Vault. So Key Vault, as an Azure cloud service, is a regionally based service where you can store secure information. And now some of this isn't necessarily new from a storage perspective, but what it provides for us is a great level of security as well as control. If you're familiar with other methods, we're going to talk about certificates in a little bit. And so you maybe have had PKI or public key infrastructure that you use certificate authorities to manage the creation and lifecycle management of the certificates that they generated. Well, that was great. You could revoke them and you could reissue them. But how did you know that they were being used? Do you know who was using them and when? This is a feature by taking those certificates that were generated by your PKI, putting them in Key Vault. You're going to get a level of security that you didn't have before, but you're also going to get a level of control and auditing that wasn't available. So this is a compelling reason, at least for me, to now still have your PKIs and some of the other methods that you might have used, but use Key Vault as the repository for the storage of that information. So we're going to take a dive into what a Key Vault is, the kind of information that can be put into it, and some of this security that we can layer over it. So I'm going to go do some whiteboarding for a bit. We'll go into a Key Vault and show these features to you, and then we'll come back to the screens here, and we'll take a look at the remaining pieces. You'll see this when I get back into the graphical interface, but similar to most things that we create, in Azure, there has to be a subscription, a resource group, and the region in which it's deployed. Now, the Key Vault itself comes in several formats that will come from a very simple Key Vault all the way to ones that are backed up with a thing called an HSM or hardware security module. If you're interested in that level of security, this ties the secure information in the Key Vault specifically to that hardware security module that's associated with it. So for whatever reason, if your information stored in the Key Vault ever gets compromised and it gets taken off of this server, it can never be used because it's tied to the HSM that's associated with the vault itself. So there's a high level of security that comes around this, especially for financial transactions. We've talked about security in a number of manners throughout the course, and we've introduced this term called RBAC, or the Role-Based Access Control. And know that every object that exists in Azure has that IAM, that Identity Access Management, and they have access control. Those are the words that you see in the graphical interface. You click on it, and I'll be doing that in a few minutes. And then you get to the RBAC. And remember, RBAC was the who, the what, and the where values that you could then use to identify the permissions that you wanted to grant to a user. Now, I want to talk a bit about this as we go through. You want to use, in all cases of security, least permissions. You don't want someone to have owner permissions on something like a Key Vault, because not only are they the owner, they can read it, they can write it, they can delete it, they can modify it, and they can do everything to the object itself. And I want to talk a bit about these. They don't get that heavily in the course, but this is where we want what's called a separation of control as we go through this. Now there are, and I'm going to use the general term, a term called owner, contributor, and reader. And then you can have, I'll just call it custom. there is a Key Vault owner. There's a Key Vault contributor, a Key Vault reader. There's also a role called owner. So I'm going to use them interchangeably here, but know that the difference between owner and a Key Vault owner, Key Vault is going to only be on a Key Vault. You're not an owner of anything else, where you could own a resource group. You could own the Key Vault in that resource group with an owner role. So there's some variations. It's not really part of this course, but know that a reader, as its name indicates, could only have read capabilities to the object itself. So in this case, you have read access to the vault. As a contributor, you have the ability to add things and remove things and change things in the vault. So you get basically the read-write capabilities to the vault. As the owner, you can do everything that the contributor can do, plus you can change its permissions. And it would be our strong recommendation that you split these three roles up across three different individuals, because remember, the information that's being stored in the Key Vault is secure information. It is basically the keys to your kingdom. You want to make sure that you need two people in collusion to be able to circumvent the security. And that's a method that we bring into a lot of our security solutions, that I need two people together to be able to potentially do something. If one person can do everything, you only need that one person to be compromised. Not that they're always doing it nefariously. That one person, if their account gets compromised, they can do, anybody with that compromised account could do whatever they want. You now want to have that separation of that control. So you want to think about protecting the vault, which we don't spend a lot of time in this course on, with the different necessary roles of RBAC to the vault itself. Now, as the contributor to the vault, or the owner, you have the ability to store several types of information into the vault. Not only can you create the vault, and we're going to show you some of the characteristics, you can then identify what kind of information that you can store in there. We talk about certificates, we talk about secrets, and we talk about passwords. Now, these two are kind of the same. In another module, you would have seen us create a secret, which was secure information in a thing called a SAS, that it had secure information or secret information as part of the SAS to gain access to the information in a storage account. That would be considered a secret. And a password, I think we all know, is some long string of characters that you use to gain access to something. So they could technically be, in some people's discussion, the same thing, a secret and a password. But those are the three types of information we typically talk about storing in a Key Vault. You'll see this come up in the Key Vault recommendations, is that we recommend that you have as little amount of information in a Key Vault as possible. For all intents and purposes, there is no cost whether you have one vault or two. It's the access to the vault that is going to be the same. So if I put all three of these into a single vault, so if I put that certificate, I put a secret and a password in there, the access to that information would cost me the same as if I built three separate vaults and stored a bit of information in each of them. So if I put a certificate in one, I put a secret in one, and put a password in another, the cost at the end of the day becomes the same. There's an administration cost that goes over top of this. It's a bit more difficult. And where this usually happens is, and where I see it in customers, is maybe you've got an application that as it goes through dev, test, QA, staging, and production, they'll have different security information. I need a different certificate to connect to the SQL connection string on a SQL database in the test environment. That's different than the connection information that I need to connect to the dev database. And they would often put all 5 of those environments, certificates or secrets, in the same Key Vault. Well, a problem with that is if the vault gets compromised, all 5 of those environments are compromised. So you'll see the recommendation come up on the slide. You want to have more vaults with less information in them as opposed to one vault with all the information in it. So the kind of information that you can put in the vault becomes these 3 kind of characteristics. Now, once the information is in the vault, I'm going to make it my certificate now. So I place a certificate in the vault. I could have an application that would need to have at least read permissions to the vault to come to the vault to get access to the information in the vault and potentially use that. Now, one of the benefits of a key vault is it can now log that information. So I now know you have to have an identity at your application. This is why we covered this so heavily in other recordings in this class. I want to be able to sign an application identity that now has to be authenticated against, say, maybe something like Microsoft Entra ID. It gets its identity. It then comes to the vault, looks at RBAC. RBAC says you have read permissions. It can now read the information in the vault, use the certificate, logs record that it's grabbed that certificate, and it uses that certificate to gain access to some information. That's a great way of using this. The other way that you can protect the information is by creating a thing called a policy. Inside the vault itself, I can protect the information with an access policy. That access policy is going to control the type of information in the vault, because you might have more than one, not recommended, but you could. What kind of information, you'll see this in a few minutes. And then what kind of permission do they want on the object through the policy. So now I have access control at the vault itself. I can also use RBAC inside of the vault. So remember, I'm trying to separate the two. One is access to the vault, and one is access to the information in the vault. So I can use RBAC to gain access to the vault, and now inside of the vault, I can also use RBAC, or I can use an access policy to get access to the information. So those are the concepts that I wanted you to pick up. We'll show those to you when we get back to the course material, but you're going to now see those live in a demonstration as I go into the interface. So to create a key vault, it's fairly straightforward. It's much like many of the other resources. I have to have a subscription, a resource group I want to create it in. I have to have a name for my key vault. Key vaults don't have some of the restrictions that other objects do. They don't have to be globally unique, but they should be representative of potentially the information that's inside of them. They are regionally based resources. And we talked about the different pricing tiers. So standard will come up, and there's that HSM features that we have. And we have multiple versions of the premium and the hardware security modules that come along with them. I'm just going to use the standard one here. There's a soft delete feature that we recommend that you use, that in case of someone deleting something in the vault, you want to be able to recover that from the vault itself without having to go back to a backup of it. Now, this does not replace the need for a backup. We still recommend that you back up your vaults, but you can actually retain that information and potentially recover it from a trash can-like recovery feature from within inside the vault. You can also enable purge protection that disables purge protection, or enable it that says, can I actually purge the vault values before I can delete it? And this goes back to that separation of control that, somebody, I don't want them coming in and deleting the vault. So they have to delete the objects, they can purge the vault, and then I can delete the vault. So you might need multiple people in collusion, as I said, to be able to work together to be able to do this, or you don't want someone accidentally deleting the vault and then having to recreate it. So it's not just always malicious. This is going to create a separation of control that really makes sure that that information is going to accidentally be deleted. We talked about the different access configurations of the information inside of the vault. I can just use an access policy for the vault, or I can use that RBAC control, and that would be the recommended method to the information. This is not the permission on the vault. This is the permission to gain access to the information in it. Now, I've got a vault already created. I'm using a policy. I'm going to go and show that to you, and you can switch it. I have a networking feature. And so very simple. It's just the creation of the vault itself. I'm going to come back to the key vaults. I've already got one created. And there's that access control IAM or RBAC features I was talking about. When you take a look at the role assignments, we can see that this is on the object itself. So this is on the key vault, and there's that owner role. Now, in previous recordings, we talked about permissions are cumulative with the exception of denies. We see that permissions are inherited from parent objects. And so you can see there's a whole bunch of people that have access to this object at the owner level, and they came from higher levels within the scopes in Azure. So we talked about a thing called a tenant and a tenant root management group. We talked about possibly up to 10,000 management groups. We talked about subscriptions. We talked about resource groups. And you can see a bunch of these permissions have come down from the root, the tenant root. Some came from a subscription. Some came from management groups. So you might want to be careful how this information is inherited all the way down. There's an example of the reader roles that are associated with this. And so you can actually create specific roles and role assignments to control access to the vault itself. Who can publish secure information in the vault? Who can delete the information from the vault? Who can consume the resources in the vault? Now, coming down to the actual types of objects, we have our keys, our secrets, and our certificates. And so I can actually generate or import each one of these types of information and store that information in the vault. So I could go to an external PKI, public key infrastructure, and a certificate authority to generate the certificate. I can import it, or I can use the features of Azure to generate a certificate for me right in the Key Vault itself. I then come in and I can take a look at the access configuration, which I set at the time I created the vault. So I actually picked up vault policies. I could switch that if I wanted to, and that you can see is the recommended method using RBAC to control access to the objects inside of the vault. Now I'm going to click on and keep it as an access policy. And so I can now create a policy. And here's the characteristics that would apply at the policy. So you can come from a template. You can see there's the keys, the secrets, and the certificates. So if I'm only storing a certificate in there, it doesn't matter what I said on the keys and the secrets, I can say they can only use a get command, or they can only use a create. So you can actually create a policy that is going to then control the kind of access that the policy will then create for that information stored in the vault. You assign that permission or the policy to a user. Now I've already got Juliet in there. Maybe you should pick another user. I think I've got. So I'm going to assign that permission to that user. I can assign it to an application and then create a policy to gain access to it. So now my user count, I could gain access to the vault if I had read permissions to the vault, and I can now use that identity to gain access to this policy that would give me the get create permissions on the objects in the vault. So there was a demonstration of the creation of the vault, the kind of information that you can put in the vault. You're seeing a lot of that on there, the certificates, the keys, and the secrets. You can see some of those best practices that we've talked about. And it's also going to give you that monitoring access. I think that that's a very important part, because in the past, I might know that an account has accessed something and it was the one that maybe misused a permission that they had, but where did it come from? When was it used? I didn't have that control. So the nice thing about the Key Vault is it's going to be able to log every time that that user or that application comes in, grabs that information and uses it. You can monitor that information. So Key Vault is a great service for you to be able to work with. So the three ways that you can authenticate this is using managed identities from Azure themselves, using Microsoft Entra ID. That would be our recommended method to be able to do that, to provide this fine-grained authentication and authorization model that you're working with. Now, there's that term called service principals. And in a previous recording, I wanted to just go to a similar screen to explain what a service principal is. Across the identity space that we have inside of Microsoft Entra ID is those top two, identities and security principles. For all intents and purposes in this conversation are the same thing. It is the general conversation around all of the type of secure identities that we can use. Now, if I were to draw a line and then break this into two pieces, identities fall into two major categories. User principals, which incorporate the previously used user principles of user accounts, which you're hopefully all familiar with. Groups, and that would be the best way to work with this. Never give anything to a user, add it to a group. So even if it's one person that needs access to something, you're better off to put them into a group and then assign the permissions, the RBAC capabilities, to the group. And by being a group member, you get those permissions or those capabilities. Now, the benefit about that is if you delete the account or get rid of the account, all you have to do is take it out of the group, and then all of the places that that group have been given access to is you clean that process up. So it makes management much, much more scalable. Because often what you'll see is somebody new will come in and they'll give them access, but they don't take the old person out. So manage them through a group, best way to do that. So users and groups. And then we had devices, that old model of Windows domain joined devices, which we now expand that to include modern devices in the BYOD world. So iOS and Android, Linux and Mac machines. Now on the far right-hand side of this, we have those service principals, and that's where that slide was coming in. Under the service principals, there's a whole new set of identities that get created, and you'll see this in a couple of slides, of system-assigned managed identities and user-assigned managed identities. With the modern landscape of application development and microservices, you now don't have one monolithic app. You potentially have thousands of small microservices that make up collectively the capability of that app. And we want to be able to assign that to each individual piece, and trying to manage that at scale, again, becomes a bit of a challenge. And so that's where that term, a service principal, comes in. We have a more full recording on that topic if you want to go watch it, but I just wanted to give that as a bit of a background from where they're talking about here of creating those managed identities. So you can have a managed identity of an account. So that managed identity might be something like a system assigned or user assigned managed identity that's given to the application. Now you can use a service principal with a certificate. Now that's probably not the best way, because now you have to manage the certificate and associate it with the service principal. Certificates usually have a TTL, or time to live, that you need to actually be able to work with it, as well as a security principal and a secret. Again, very similar. That secret has to be created, maintained, and managed. So our recommendation is to use the managed identity to gain access to the resources in the vault. Here's some of those recommendations that I talked about during the creation. We do recommend separate key vaults, and it's not adding cost, it's the access to the resources. So if I have two objects in a vault, the access to those two objects, if they're used exactly the same amount, would be the same as if they were two separate vaults accessed individually with the same amount. You're going to get roughly the same cost. So what you're trying to do is to minimize the blast radius of a compromised vault, so that if a vault ever does become compromised, you're only limited it to the information that was in that vault, so a very small amount. You want to control the access to the vaults. That's that RBAC permissions that we talked about at the outside. So yes, we can use RBAC to gain access to the information in the vault once you're in there. And yes, you can control it through policies, but you want to make sure that you're controlling access to the vault itself. While we have a soft delete and a purge capability that you can restrict at the vault level, you still want to make sure that you're performing regular backups to meet your own requirements. And this is a feature that I love about Key Vaults, is the logging capabilities. You can now use this not only for monitoring for troubleshooting, but you want to make sure that you can now see potentially malicious behaviors, because if you see a whole bunch of attempts trying to access a Key Vault, that could be an indication of a precursor to an attack. So like, why is someone trying to connect to that vault? Or you could just see some person that is maybe having some challenges, and you can step in and help them with that. So, and then finally, those recovery options that I've already mentioned for you. So while we have these two types of identities, of system assigned and user assigned managed identities, both available through the Microsoft Entra ID tenant, our recommendation would be to have that system assigned managed identity. The big difference here is a system assigned managed identity has a one-to-one relationship. That identity is tied to one application or one service or one allocation to whatever is being assigned to. And they share a common life cycle. So they are tied together, makes the administration much easier. In a user-assigned managed identity, they don't share a common life cycle, and that one identity could be used across multiple locations for the assignment of it. And so this makes it a little bit more difficult that, let's say we had two services that had the same user-assigned managed identity. I would only know that that managed identity came to Key Vault to get the service. I don't know which one of the applications in this case was the one that used it. So system assigned managed identities would be the recommended method to be able to get access to this information. We've talked about authentication and authorization. So the authentication to the Key Vault to gain access, especially from an application code, is available for you. We've got a whole set of different SDKs, depending on what your development platform is, that all provide access to the methods that we're talking about. So let's go off and do an exercise of creating a Key Vault and then accessing and building an application to be able to access the information in the vault.
In this lab, I'm going to create an Azure Key Vault, store some secrets using the Azure CLI, and then build a .NET console application that can create and retrieve secrets from the Key Vault. Let's get into this. I've previously been inside of Cloud Shell. If you've never been in here before, you're going to have to do some configuration. And I'm going to instantiate some variables that I'll be using in my script. It's going to create a Key Vault name, the region in which I want to deploy the resources, and it's going to have the resource group. This is going to create the Key Vault resource. This is going to retrieve the user principal name for the account, and this is going to represent the role that was going to be assigned. This is going to retrieve the resource ID for the Key Vault, and it's going to set the scope for the role assignment that we are going to specify for the Key Vault. This command will create and assign the Key Vault secrets officer role. This is going to create a secret. This command is going to retrieve the secret to verify that it was set. These commands are going to make the directory and then change to it for my application to run in. This is going to create the .NET console application. These commands are adding the Azure.identity and the Azure.security.keyvault.secrets packages to the project. This is going to begin editing the application. I'm going to save the application. I'm going to run the application. Option number 1. Go list that information. So I've been able to create a secret, store it in the Key Vault, and retrieve it. That ends the lab. Let's go back to the recording.
Welcome back. We're now going to close out the module with our knowledge check. So question number 1, what method of authenticating to Azure Key Vault is recommended for most scenarios? Go ahead and pause the screen. Welcome back. Managed identities would be the best way, and specifically system assigned managed identities. Question number 2. Azure Key Vault protects data when it's traveling between the Azure Key Vault and the clients. What protocol does it use for encryption? Go ahead and pause the screen. That would be TLS, or the Transport Layer Security. So this brings module 1 to an end, where we've described the value of what Key Vault provides in your security in authentication and authorization to secure information, whether it be certificates, secrets, or keys. This information needs to be stored securely, and Key Vault provides a unique opportunity to bring a high level of security as well as auditing that might not have been available to you before. Key Vault is a great tool that provides a full range of tools for recoverability, for manageability, to be able to keep that information safe and secure and scale in the modern application development, especially when we get into microservices. We've seen how it is authenticating and using the policies of either an access policy or RBAC to gain access to the information. We now have granular control to the information inside the vault. So thank you for joining me in this recording to understand what Key Vault can do for you. I look forward to seeing you in another recording.